Okay, so there's this question that pops up quite a bit, and it's a good one. Why does the Air Force have the F-35B, the jet that can hover, when the Harrier, which was famous for doing just that, was phased out? It feels, well, kind of contradictory, doesn't it? So today we're doing a deep dive into that. We want to unpack the story here, trace the evolution from the Harrier to the F-35B. And it's not just about the jets themselves, fascinating as they are. It's about understanding the huge leap in what they can do and the thinking behind military aviation choices.
That's a really key point to start with. And we should probably clarify that first bit for you straight away. While the question often mentions the Air Force, we're actually going to find out exactly which parts of the U.S. military use the F-35B. And we'll see how it connects directly to the Harrier's legacy, but definitely not as just a straightforward replacement. More like a revolution, really.
Yeah.
So the mission for you listening in is this. By the time we're done, you'll get the real reasons behind the F-35B's development. You'll grasp the pretty dramatic tech advantages it has over the Harrier, and we'll sort out where the different versions, the A, the B, and the C, fit into the U.S. military picture. We're covering the what and, crucially, the why it matters.
Okay, let's dive right into that leap then, because the F-35B, it really changed the game for tactical aircraft. When we say it's a fifth-gen fighter, what does that actually mean? Like, for the person in the cockpit or for the strategy on the battlefield? Especially next to the Harrier.
Right, that's a great way to frame it, because fifth gen, it's not just jargon. It really signals a fundamental shift. With the Harrier, you mostly had a pilot looking out, relying a lot on their own eyes, maybe a fairly basic radar. Don't get me wrong, it was an amazing specialized machine for its day, but it operated more like a solo performer. Highly skilled, but solo. The F-35B, though, it's not just about being stealthy or faster, though it is those things. Its cockpit is more like a networked command center. Imagine the pilot seeing everything. A full 360-degree view, data fused from its own sensors from other aircraft, drones, ground units, all in real time. Yep. They're not just flying and fighting. They're managing information, making decisions faster than ever thought possible. This sensor fusion, this situational awareness, it's a strategic edge the Harrier just couldn't provide.
Okay, so the Harrier was an incredible piece of engineering for its time, particularly that STOVL capability, but you said it made significant sacrifices. What were those trade-offs, practically speaking?
Absolutely. That short takeoff, vertical landing STOVL, it was revolutionary, no doubt. But it definitely came with costs. The whole design was optimized around generating that vertical thrust. And that meant giving things up in traditional fighter performance. For one, it was subsonic. It couldn't break the sound barrier.
Right.
Its range wasn't great either, relatively speaking. And its payload, how many bombs or missiles it could carry, also quite limited compared to its contemporaries or modern jets. He was brilliant in its niche, but it wasn't the multi-role powerhouse we expect today. It traded speed and carry capacity for that unique flexibility.
It really puts the Harrier's achievement and its limits into perspective. Okay, so now the F-35B, you mentioned it carries a much wider range of weapons and this AESA radar. Now, for those of us who follow this stuff but aren't radar engineers, what's the big deal with AESA? How does that change things for the pilot? Why is it such a game changer?
The AC radar. Yeah, that's a perfect example of the technological jump. AESA is active electronically scanned array. Think of older radars, maybe like a single big flashlight beam sweeping the sky. Right.
Yeah.
And AESA is totally different. It's like having thousands of tiny individual radars or flashlights that can all be pointed electronically instantly in different directions. So it can track lots of targets at once, switch between air-to-air and air-to-ground nodes almost instantly, map the ground in incredible detail, and even perform electronic warfare functions like jamming, all while being much, much harder for an enemy to detect. It's incredibly versatile and stealthy itself.
Wow. Okay.
So that multifunctionality and stealthiness, it radically boosts the pilot's view of what's happening, that situational awareness we talked about, and an unparalleled view. And yes, combine that with the F-35B's ability to carry a much larger and more diverse loadout of modern smart weapons. Well, it means it can handle more targets more precisely from further away. It's just a massive capability upgrade for the folks who used to fly the Harrier. A whole different league.
Okay, so we've covered the tech leap, which is huge. Let's circle back and make sure we're crystal clear for everyone listening about who in the U.S. military actually operates these different F-35 versions, because that seems to be the root of the original question.
Yes, absolutely essential to nail that down. It breaks down pretty logically based on roles.
Yeah.
The F-35B, the STOVL one we focused on, that's exclusively operated by the U.S. Marine Corps.
Ah, the Marines. Okay.
Exactly. It directly replaced their old AV-8B Harriers.
Yeah.
It lets the Marines keep doing their unique thing, operating from amphibious ships, small forward bases, but now with a full-on fifth-gen fighter. Then you have the U.S. Air Force. They fly the F-35A. That's the conventional takeoff and landing version. Think standard runways.
Got it. Land-based.
And finally, the U.S. Navy operates the F-35C. That's the carrier version. It has a bigger wing, stronger landing gear, the tail hook, everything needed for catapult launches and arrested landings on those big aircraft carriers. So A for Air Force mostly, B for the Marines, think STOVL, and C for carrier Navy, each tailored for its mission.
That clarifies it perfectly. So stepping back to look at the big picture, this whole Harrier to F-35B story, it's more than just swapping out aircraft models. It really shows how military tech is constantly pushing forward, right? Trying to meet these really complex needs, balancing something specialized like STOVL against overall combat power, stealth, those advanced sensors. It's a constant balancing act.
Precisely. It illustrates that relentless drive for better performance, for strategic advantage. You see this specific need the Harrier met, the compromises it made, and then how technology allowed the F-35B to retain that STOVL niche, but package it within a vastly more capable, multi-role, stealthy platform. It's about evolution, meeting threats, and projecting power in new ways.
Okay, so wrapping this up then, let's think about what this means for you looking ahead. We've seen the incredible step up with the F-35B, but also acknowledge that even it has trade-offs, like maybe a bit less range than the ARC model for that STOVL build. So thinking about that balance, what do you suppose the next big leap in aviation tech might look like? And what kind of sacrifices, what kind of trade-offs might that demand? Something to ponder.